Hello everyone. In this video we will begin to examine topic 7.3, the structure of matter, and in particular we will begin to discuss the models of the atom. So topic 7.3 takes us to our most advanced physics. Basically, the majority of physics research from the 1930s on has led us to what is known as the standard model of particle physics. It's our best understanding of the fundamental physics that govern the interactions between different particles and those most fundamental particles. But to understand where we are, sometimes it's helpful to have at least a brief discussion of where we've been and how we've gotten there. And so I want to cover, at least briefly, a very short history of some of the models of the atom that have made up our sort of history of the best understanding of our best understanding of the atom. Some of you will note that many of these models are things that you were taught at one point. And in that sense, we'll be taking both a historical trip backwards in time of our best science, as well as a sort of personal history of things you have been told about the atom. So, in that regard, we'll start at the beginning with the origin of the word. Atom comes from the Greek root meaning indivisible. And the idea is that atoms were the smallest constituents or parts of matter. This idea, with no sort of scientific evidence, only sort of philosophical thought experiments, came from Democritus, who lived about 400 years BCE. And the idea is that if you continue dividing matter, eventually you will get to sort of a smallest piece or a smallest chunk, and that is what was known as the atom. Sort of our next leap forward came from John Dalton, who observed that if you hypothesize that atom came in sort of these small spheres or billiard ball shapes, and that different elements were composed of different atoms, that you could use that fact to observe and predict the ratios of particular compounds after particular chemical reactions. This is sort of the foundation and the founding of what we think of as modern chemistry and stoichiometry. You'll recognize that if they're combining to form compounds in whole number ratios, that is the essence of stoichiometry, is that we can use that fact to predict outcomes for macroscopic variables like mass or volume. Okay, and this idea sort of was our early 1800s understanding of the atom. Think the understanding of the atom that we visualize and use when we talk about the kinetic theory of an ideal gas. This is the same idea. Then we sort of move forward again in 1904 with a few experiments conducted by J.J. Thomson, who, using something called cathode ray tubes, which were devices used all the way up sort of even to sort of close to the present day in the form of CRTs, which is the old model of television. Those are cathode ray tube televisions, which involved taking a filament, putting it at sort of a high temperature, and applying a large delta V, a large potential difference across it. And in this way, he discovered the electron. That is, he discovered that there were small, dense, negatively charged particles which made up the entirety of the negative charge of an atom. He did this by measuring very carefully the charge to mass ratio and discovered that these were not only negative, but had a significant negative charge compared to sort of the rest of the mass of the atom. And this is the sense in which we say he discovered the electron. He discovered that the negative particles in the atom, the negative charge in the atom, was bound up in these tiny, dense little packets known as electrons, or today as electrons. And so his model of the atom, the model of the atom that came to be known as the plum pudding model, was sort of evenly distributed positive charge throughout the atom, with the idea that the electrons form sort of little plums or little raisins in a sort of packet of dough, in tiny packets, which we eventually came to call electrons. And those are sort of the first two models of the atom that we'll cover. In the next video, we will spend a lot of time unpacking the sort of next step to our modern understanding of the atom.